So we are here with Brendan Asselstine from
Brendan Asselstine. From PoolTogether.
Okay, from PoolTogether.
Hi everybody, my name is Brendan Asselstine from PoolTogether. I'm really excited to be here because last year we debuted PoolTogether at ETHDenver. That's where the hackathon project started. So it's really cool to come back. This is kind of like our homecoming, our anniversary. And so I'm happy to present how we actually build the front end, because prior to PoolTogether, we had actually been running a dev shop for about a year. So in total, we've been building dApps for about 2 years now. And so I want to share some of the insights that we've gleaned from basically doing the data binding with the front end, because that we found was the hairiest piece, because dealing with an Ethereum node and talking to it directly can be very complicated. So this is what we're going to cover. We're going to cover an introduction to GraphQL. We're going to cover how PoolTogether leverages GraphQL. And we're going to build a dApp very quickly. I actually have a lot to cover, so we're probably going to just zip right through that, but there is a tutorial online. And then we're going to extend the dApp using the Graph Protocol. We really like the Graph Protocol. It gives us totally flexible data, so we can actually go back and, as we're going to do, we're going to get a churn report as well as the existing subgraph. So you can build as many subgraphs you want, so you get as much data as you want. And then finally, we're going to finish with discussing EIP 1767, which is really important because that's the Ethereum client GraphQL endpoint standard, which is slowly permeating through all the different client implementations. So it's not quite there yet, though, because we're really waiting on Infura, because people don't necessarily want to run their own nodes all the time because it's complicated. When we did it with AWS, we got shut down because they thought it was a spam bot, because with all the peer connections, it was just crazy. And then I want to close with questions. So this could be stuff about PoolTogether, smart contracts. It can be about the GraphQL work or anything. So let's jump in. Out of you guys, who has experience with GraphQL? You've played with it before? You played with it before? So I'll kind of fly through this then, because it's pretty straightforward. So GraphQL is a language to define, query, and mutate data. So and that's at its core what it is. It's just a way for you to communicate with a server. It's just a language. The actual implementation could be anything. You can use Postgres, you could use Redis, you can basically bind it to any data source. You just need GraphQL resolvers to be able to return the data as you need. The other half of that is the GraphQL query language. So once you do define your type definitions, you can then query it in a nested way using the query language. So let's have a look at that now. So this is a super simple example. It demonstrates that you can set enums. So enums can be basically treated like primitives once you define them. Then you define your entities. In this case, we define a starship. I actually pulled this off the Apollo client example sheet. And the ID is very important there. You can see that it's ID exclamation mark. And this really helps clients cache data, because knowing the ID and the type of an object, it's very easy to store it client side and refresh it only when you need to. And then you can see we've got the name definition, and then we have length as well. And it's interesting to note here that length is a function. So we're actually passing it a unit, which it then will affect the size of the float that it returns. So if it's meter or feet, that'll be what the length returns. And then on the right side, this is actually a very special type query, because these are the top level queries where you start in your GraphQL query. So everything will have to start with starships or starship. And then within starship, you can select one of its attributes. You can also have associations, so you can select other entities within that. And here you can see, so starships on the right, it returns an array as defined by the square brackets of starship. And then the singular one, where you pass an ID, returns a singular starship. So this is what a query looks like. You can see that you can pack as much data in here as you want to. And this is one of the serious benefits of GraphQL, and that you don't need to do a bunch of different queries to pull in a bunch of different data. You get exactly what you need. And you can see that here in the hero : starship. So we've called that top level starship query, and we tell it we want the ID and the name, but we don't need length. So we don't even tell it that we need that. So it's not going to return us that data. And then we rename it as hero, so that in the front end, we can just go data.hero and access it that way. And then finally, you can see that we're accessing all the starships as well. So why GraphQL? Why is it so useful? Why is it important? Because JSON RPC APIs, like existing HTTP RESTful APIs, mean you're either overfetching or underfetching your data and you're doing a lot of queries. You're just drilling your server with all these different queries, pulling in your different model data points. So using a single query, you can grab all the data that you need, no more, no less. And this is one reason why Facebook championed this technology, was because they developed so many different apps. And all these apps wanted to pull in Facebook data, but they were pulling tons of data. So they're like, okay, we need to solve this. And this was a great way to solve that problem. One thing I do want to note, though, about the queries is that GraphQL doesn't have any concept of skip or offset or any kind of like count or aggregate functions or anything like that. It's purely just a language which you can represent that. So in your actual implementation, however you build that in the server, you can be like, okay, well, we'll implement paging this way. Like Graph Protocol has implemented paging in a very certain way. So it's a very, very loosely defined. I think that's one reason why people have a hard time understanding it. The other major benefit of GraphQL is because of these type definitions, you can see what your server's offering. It allows you to introspect the API without needing any kind of documentation, because the servers will serve up this type def so that clients know exactly what they can query. So using a GraphQL server, you can just point an off-the-shelf tool such as Graphical at it, and you'll be able to explore your API. We could actually take a quick dip out to the Graph Protocol, because you can see that here. Once you have a subgraph, it's a little grainy there. Let's boost it a little bit. But you can see your schema over here. So if you go to our top level query, we see it's this entity pool prize, and you can click on it and then see all its different values. So it's super generic. It's really, really practical, really handy that way. And so generally, what does a GraphQL app look like? Given how abstract this language is, how do we actually integrate it? So like I said, that you can use Postgres, Redis, whatever your backend database is, you can just build a GraphQL layer on top of that. Typically an HTTP endpoint that you just send queries. And then your client can query the endpoint just using raw strings. Just queries, just assembled as strings, super simple. But typically clients will want to use a framework such as Apollo Client or Relay, because they have really elaborate caching mechanisms. So they only request the data when it's fresh, when it's new. It needs a little bit of help to push it along in that way, so that's why versioning and other things are built on top. But out of the box, they're really powerful, and they really can help speed your application up. It's important to note as well that a lot of these queries, they're being fired off from the client to the server, but you can also fire off queries to client-side resolvers, client-side query resolvers. And this is a really cool feature that we've used and abused in PoolTogether, because it means that we can interface with Ethereum node really cleanly. So this is a powerful feature. It's not standardized though. It's different in Apollo Client and Relay, but we'll dig into that. So how does PoolTogether use GraphQL? Well, our architecture is very simple, and it kind of originates out of some of our first clients when we were a dev shop, in that they were very ideologically opposed to having a server or any kind of centralized anything. Even having a static front end on Netlify, I was like, okay, we're not going to use IPFS, let's do this. So really, all we have is a static web app, we've got our smart contracts, and we've got our Graph Protocol Subgraphs, and finally Infura, because running a node is challenging, and they've nailed it. And so, like I mentioned before with these client-side resolvers, we use Apollo Client in two ways. We have our client-side resolvers talking directly to the Ethereum nodes, and then we also have like normal GraphQL queries that get fired off to the subgraph. So the client-side resolvers are kind of special as well. Because they're custom to Apollo Client, we decided to extend Apollo Client with our own framework. Interesting to note that last year at ETHDenver, there was a project called ETHPollo. I like to say ETHPollo because there's a big chicken, so it's clearly Mexican in nature. But they effectively implemented something similar to what we did, except we took it a little bit farther, because we've now integrated multi-call, a smart contract by Maker. That's really cool, because you can basically compile an array of all these different calls, smart contract calls, and send it to it in a single ETH_call to the JSON RPC API. And the smart contract will go and execute all of those and then return the bundle of data. So you can batch these calls together. So you can, in your queries, you can pile in, say, a dozen calls, and they come back instantly in one shot. So it's been a huge performance improvement for us, and we're really excited to be able to launch with that. And then, of course, we have other things. Because we're interfacing with Ethers.js, you want things like the current network, their account, blocks, the current block, past events, all that kind of stuff. We also support transaction mutations, but that API is mutating itself, so we don't want to go too public with it. So let's have a look at the Tightbeam query. So this is our local client-side resolvers that are communicating directly with the Ethereum client. We can see that, as mentioned before with these sort of top-level queries, previously it was Starships and Starship. Here we've added our Tightbeam top-level query call, which corresponds to ETH call. And we've renamed these with GraphQL aliasing. You can see the green balance, total supply, and DAI balance. Any resolved field can be renamed client-side, and it makes it really handy when you need to switch things up but keep the same name so you don't have to change your front-end code. And then what defines it as a client-side resolver is a little @client on the very end there. But you can see that this is really readable. We're wanting this contract, pool DAI, the function's balance of, and then we pass it the user address. So that's another important thing to note, is that queries can take variables as well, parameters rather. So let's build a dApp. I can see there's not a lot of laptops out, so we're going to rip through this really fast. I'll just go through the README, because there's a tutorial that is basically a verbatim cut and paste code. It's stupid simple. So you can basically recreate the exact app we're building just by cutting and pasting. So let's hop over to GitHub. I know a lot of people don't like the style of GitHub, but I've gotten used to it, so I don't mind looking at it. So bear with me here. So first things first, we want to set up the app. And so we use Next, because Next.js is dead simple to use, comes with a lot of configuration out of the box. We don't want to mess with Webpack configs, we've done enough of that. So this has a lot of great out-of-the-box features, including server-side rendering. So you can actually render part of your application server-side, which then gets loaded, and then the rendering is completed client-side. So that's all pretty straightforward. We include ethers, Apollo client, everything we need. Now, this is the most complicated piece, I'd say. So this is where we initialize Apollo client. And Apollo client, a big part of it, like I mentioned before, is the caching mechanism. So you want to create your cache right here. And then we need to set the default cache data. So this is stuff like, in our case, this is setting transactions. There's a certain shape we expect, which is just an empty array. Because that means your front end won't choke on it, and you don't have to do null checks everywhere. It's nice and simple. And then next, we attach the Tightbeam resolvers. So these are the client-side resolvers that communicate directly with Ethereum. And then finally, we link. So this is a really crazy abstraction that Apollo has, but it's actually very cool. It works kind of like HTTP event sort of handling server-side, if you guys are familiar with that. It's a chain that gets passed on to the next and next and next. So in our case, we want it to hit our Tightbeam multi-call link, which will batch all the calls. And then it'll get passed on to the state link, which is the client resolvers. So it goes one at a time, and the multi-call link is able to batch everything. Then finally, we return the Apollo client here. So, and this is what we love about Apollo, is now the front end, once we create it, we just pass it to an Apollo provider, which sets a React context so that you can pull it in anywhere you need, nice and easy. So next step, let's integrate the ABIs. We've now used NPM and versioning, so you can pull in our ABIs versus using NPM.js. But in this case, we're just going to pull it in from Etherscan, nice and simple. So you can just create the JSON files locally in libapis. And then this is the other part of Tightbeam that makes things really easy to use, is you actually instantiate it with an ABI mapping. So this maps contract names and networks to addresses and ABIs. So that means when we do that previous call, as you saw over here, when we say pool DAI, it knows exactly what we mean. It's like, oh, okay, I'll just figure out what network we're on, and then because you use this name, it'll be this address. So it makes things really convenient when you have, say, a front-end app deployed to Coven and mainnet, and you just want to switch back and forth, and it just pulls in the addresses stupid simple. You don't have to do any work. And it'll re-trigger all the queries, nice and easy. So here you can see we add a contract, there's the address, there's a JSON. We're going to add it to Tightbeam as a part of the options you pass to the constructor. And then let's display some things. So this is where things get fun, because this is what we love about this framework, because it separates your retrieval of data from Ethereum, which is a nightmare, from your actual rendering of the components. And in this case, you can see that all we do is we define at the top a query that pulls in the different supplies we want from both pool and our pool tokens, or excuse me, DAI and our pool tokens. And then down here, we render it. So we're using React hooks here. So we're going use query with our query. And then once we have the data populated, we just render it down here. So this is step 4. So let's quickly jump to that and just demonstrate. So I believe I'm in the right, yeah, so let's go step 4. Oops. So as part of the app repos, there's branches for each step. So if you want to jump ahead, if you don't want to mess around with editing, you can just check out the branch and easy peasy, it's right there. So we'll go yarn, make sure everything's ready to go, yarn dev. So this will spin up the next server, and then we'll spin over to localhost. And give it a second. So there we go, nice and easy. Loads pretty quickly. Oh, hey, that's cool. These values are static, but why don't we make them dynamic? If we switch over to here, let's just move that into the background and open up our component here. So now we're looking at the actual source code. So here's use query. Let's add a polling interval here. So if we go poll interval 2000, this will spin up again and should re-render. Might have to save this again to re-trigger it. Here we go. Let's just yarn dev again. And now, every 2 seconds, that query will refresh and update these numbers. So with very, very little code, we're able to make a very responsive UI. And then you could hook up events, you could hook up, Graph Protocol subscriptions. There's all sorts of different ways that you can have it trigger and refetch these queries. So jumping back to GitHub, we set up our token supplies component. That's all done. And then we integrated that into our index. So you can see token supplies being rendered here, nice and simple. And now this is the next step. So smart contracts are great in that it's always available, super robust, highly distributed, yada, yada, yada. But they have no reporting mechanisms built in. So if you want to do interesting data visualizations or have some kind of interesting time series info, like I want to go back to block 600 and see what our deposits were, technically that's possible with Ethereum, but Infura shuts that off. So that's a very highly paid feature. So if you want to introspect that kind of stuff, using Graph Protocol makes it super simple because you literally can just pass the block number as part of the queries. So, and I've actually been really impressed with how much Graph Protocol's improved over the last year. Previously, you had to do this whole Docker setup that was very challenging. But now, it's incredibly streamlined. And we don't even need to run it locally because it works so fast on their hosted servers. So, and not only that, but initializing a project, you can just pass it an address. It will pull in the API from Etherscan, set everything up for you. So all you need to do is fill in the blanks. So here we initialize the project, graph init, very simple. Let's have a quick look at that code. And what it sets up is a basic project, and it creates a mapping file. So based on the API that you provide it, it sets up all these handlers for every single event that's fired by that smart contract. So it's very easy for you to just have this template to work within. It also has the subgraph YAML file. So this defines the address that it's actually pulling from, as well as the start block. And I highly recommend if you create subgraphs to add the start block, because that'll speed things up tremendously in the front end. It won't have to process like years of blocks from way back when. So jumping back, so here we set up the correct address, because I actually, up here, this is the implementation. Down here is the proxy. So it's PoolTogether smart contracts are upgradable, so there's a separation there. Because if we pointed at the initialization at the proxy, it would have created basically the Zeppelin upgrade ABI code, which is not what we want. So now we define our schema, and this is the fun part. What questions do we have for our application? What do we want to find out? So for PoolTogether, let's find out what the churn is. We want to know how many people onboard and how many people drop off per prize. Pretty simple analytics to look at. So first thing we do, if you recall the type definitions from earlier, is we're going to define a pool prize type. So of course it has an ID. They all need IDs. We're going to tell it the draw ID. There's a bit of a confusing nomenclature here because we say draw, but it also means prize, but just don't worry about it. And so for each prize, we want to track the number of deposits and the total deposits. Likewise for withdrawals. So very simple stats. That'll tell us the inputs and outputs per prize. Easy peasy. So we'll call yarn codegen now, And that will, the Graph Protocol project that we set up will already know how to populate that. So let's actually check out, that's step 6. Actually, I don't think that's right. I need to refresh this page. Step 2. There we go. So let's go back to here. We'll check out step 2. We'll go yarn code gen. And the graph will do its thing. So here it's generating your actual, like the entities, the TypeScript representation of the entities, as well as, I guess here building it into WebAssembly. So it's it's doing a lot, I believe. Maybe that's the yarn build step. Actually, I can't remember. So now that we have our schema defined, that's our end result. That's what we want. Now we need to process the events. And this is really cool. So this is a process, I don't see it mentioned anywhere, but it's called event sourcing, where you actually have a static, immutable history of events that you want to replay into whatever data shape that you want. And the cool thing about it is that you can just scrap that shape of data and then just replay it and regenerate a new, what they call a projection, like what the shape of that data looks like. And so I wanted to play with this for a long time. So Graph Protocol, they make it stupid simple to do. And so what we want to do here is we don't want to start processing the events, because the events in our Ethereum history are these immutable little logs that we want to basically replay and kind of rehydrate some data structure. In this case, all the pool prize that we define. So I do a lot of description here about how PoolTogether works. So that's if you read the tutorial. We can skip over that because people still don't understand it, how we have this open and committed phase to prevent people from gaming the system. But anyway, that's further reading if you like. So let's handle the opened event. So when a new prize is opened for deposits, the open event is fired. So what we're going to do is we're going to create a brand new entity, our pool prize entity. Its ID is going to be our draw ID that is included with the event. And we're just going to default these different parameters. Nice and simple. And then we'll save it. And behind the scenes, Graph Protocol is doing all this fancy business with Postgres, so we don't have to worry about that, exactly how that works. And now let's handle the deposit event. So just to illuminate this a little bit, so this is the source mapping file that was generated along with the project. You can see here all the empty handlers. We're just filling some of these in. That's all we're doing. You can leave a bunch of them empty. You can fill only one of them in. You can do whatever the heck you want. Easy peasy. So now handle deposit is done, and we have our deposited information, the count and the amount. So we'll do the withdrawal as well. This is basically cut and paste, I think. This is very simple, very straightforward, same thing. And we're done. So let's check out step 3, so we're all caught up. And we'll just use yarn cogen again, just in case. And yarn build, just in case. Make sure everything's tickety-boo. Yep, we're good to go. So now we deploy. And this is so great. It's so simple. So I'm actually not going to navigate to the Explorer. And this is for you, Yaniv, because it displays our API keys. So I can't actually show that. I mean, it's a bit of an operational security problem there. So maybe if that could be hidden by default, then I could display it. So something for you guys. But yeah, so I've also added this little helper. Actually, this might be another nice thing to add, just to auth very quickly against the Graph API. So what you do is you go yarn auth and then your access token. Nice and easy. So I've already done that though, so none of you can see my access token. Not that anyone would really take it, I'm sure. And then to deploy, we go yarn deploy. So I believe this is already set up. So let's go yarn deploy. Let's check out the latest state. Step 4. And let's just do a quick check. Yeah, that's the last one. So what this is going to do, it's going to build the WebAssembly and then upload all of the assets to the graph. So this is their hosted version of the system. And if we jump back to the Explorer, let's see. We can see now that there's a pending version, and it was really fast because I guess we're only processing 2 events, so it's just like very quick. It's important to note as well that I actually skipped this step. You need to create this through their website. You can't create it through the command line. You've got to bootstrap your subgraph through their interface, and then you can deploy to it. So that's something important to note. So let's jump back to our app here. So great, so it's all loaded up. We've done it. Now we can actually look at it through our Explorer here. So they have a really great little auto generation system here. So we actually have a default query. And now if we hit play, It's kind of challenging to read. It's very small. Let's hide the schema first of all. Maybe that helps a bit. Anyway, let's hit play. And we can see here all the data that's pulling in. And we can request exactly what we want because it's GraphQL. Let's just skip that. We'll just get the draw ID. You know, easy peasy. So, and this again is the benefits of GraphQL. You pull in, you're just sipping data, only exactly what you need. After we kind of went public with the DAI pool, our Infura usage exploded. We went up to 6 million a day. It was crazy because of the way the front end was built. So the multi-call really helped with that. It batched all the calls down into a single call, which is really wonderful. We've also started polling less because there's still a lot of polling. We use Ethers. They don't yet have a WebSockets implementation, so we're kind of waiting on that. But for the time being, the graph has really improved. So we're kind of transitioning more and more data to the graph. Although we still want to have a few things straight from an Ethereum node because then your reliability is much higher. Your service uptime is much better. We have seen a few drops here and there. So now let's integrate this in the front end. And this is where Apollo Client shines. I'll just jump back to our code here. So integration now, because we defined our client-side resolvers, which was effectively abusing the Apollo client-side resolver system. Now we can just use Apollo client as it was meant to be used, which is communicating with a regular GraphQL server. So back to our create Apollo client file. All we do now, like I mentioned before, how the queries get passed from link to link to link to get processed, and how they started with our multi-call, then they went to the state link for the client-side resolvers. But now, if a query didn't have the @client attached to it, it would need to be fulfilled by something else. And so now it's going to be passed on to the HTTP link, which is now communicating with the Graph Protocol Subgraph there. And this is a dirty hack right here, because Next.js renders in both the server and the client. And so it can really bite you in the ass sometimes. So that little clause helps prevent it from choking. So now that's set up, going back to our components, let's just add a new component, and we'll just pull in the prizes query here. So now we're going to pull in all pool prizes. There's the ID, deposit count, deposit amount. Super simple. Going back down here, we've just got another React hook, and here we render it in a table. I know, I still use tables. I'm not supposed to. So let's see what that looks like. So that's step 5. So if you go back to our front end, we'll just kill that GCA step 5, and then we'll go our dev, kick it back up, and failed to fetch. Why? That doesn't make any sense. Okay, well let's see here. I might have configured something wrong. Am I connected to Wi-Fi? Yeah. Always the demos. Oh, there we go. I don't know what happened there. So now we can see it loaded super fast. We have all the information here that we want. I actually had some surprising numbers here. I realized that we had significant churn in some cases, but it's probably just the whales entering and leaving. They create a big splash, so you got to watch out for that. In addition, this doesn't include the SI migrations to DAI, so we're missing a few things here. So as you can see, it's really simple to make this data live using a polling interval. We could even do the same thing for this, but GraphQL supports subscriptions, so you can get the WebSockets push for new data. So it's very convenient that way. I haven't yet played with that. We have a lot of legacy code as well. So that's the beauty of our client-side resolvers as well as Graph Protocol in tandem, creating a really awesome front-end experience without having any server-side code. So we're really stoked on this structure, and we think it's going to last for a long time. So the last thing I want to talk about, because this is really important to talk about, is EIP 1767. So back in, I think it was January 2019, Nick Johnson completed the GraphQL endpoint for Geth, which is a big achievement. It's super complicated, and it allows you to query all this nested transaction data, which if you're using the traditional JSON RPC API, you'd have to do so many calls to pull in all the little different bits and pieces that you needed. So now with a single GraphQL call, you can pull in all the transaction, the logs, and everything associated with it, and it's very efficient, just sipping data over the wire. Very nice. At the same time, Raul Kripalani and Chris Shin from Infura were developing ETHQL, their own GraphQL implementation. And so they fantastically combine their efforts to create EIP 1767, which apparently was mostly ETHQLs. I guess they aligned it to that. But it looks like the adoption hasn't proceeded quite as quickly as we might have hoped. Because we have full client support in Geth and Pantheon. Infura has stated that they have the sort of standard ETHQL, then they have the extended ETHQL, which offers all of their additional bits and pieces on top. But there's no public endpoint that you can communicate with. So it might be just dormant right now, the project. I'm not sure what's at. Parity has partial implementation, and so we're seeing some functionality across the different clients. That being said, we interface with Ganache so much that having it in Ganache would be really essential for local testing. So we're and that's why we have our client-side resolvers, because we're getting the batching of all the calls. We're getting that sort of advantage, but we are able to work across Ganache and any other client that we need to do. So it's a little crude and it's a little abusive to GraphQL, but it works really well and it's super fast. That being said, this will eventually happen, I'm sure. For us, though, as a dApp, it's a little less relevant. It's more for, say, blockchain introspection. Like if you wanted to build an efficient Etherscan, you would definitely want to use the GraphQL endpoint for all the block data, transactional data, all that stuff. But we're communicating with smart contracts, so 90% of our calls are just ETH call. Very simple. So I want to open up the floor now to anybody that has questions about PoolTogether or smart contracts or our history or GraphQL or anything really.
Actually, is Yaniv from the Graph here?
Yeah, and we've got Yaniv over here as well.
Right. He's our next speaker, and we're out of time. But You'll be here all weekend, right?
Oh yeah.
So you have plenty of time to ask him questions, because we got to get him up real quick.
Okay, well maybe save your Graph Protocol questions for Yaniv then. But does anyone have any PoolTogether questions, anything like that? All right. And that concludes the talk.
You're actually out of time, so we got to get him up.
Okay, perfect. Well, thanks everybody. Appreciate it.
Thanks.